Now, what are the different types of load? So, on a broad scale, loads are classified into four types. First type, or the basic one, which we call it the normal load. So, what is a normal load? So, normal load, it requires a standard power supply for any electrical load. There is no requirement for automatic restart after a voltage drop or power failure. So, no critical or emergency power supply is required in this type of load. When it's closed, it's okay. It will not hamper the process or safety or shutdown of the plant. The failure of the power supply to these normal load at any duration has no safety. So if suddenly due to any failure or a dip in the voltage, this normal supplies get out, then what will happen? There will be no impact on the safety of the plant. Next type of load, we call it as the essential load. From the term you can understand essential means important. So these are the loads which are essential for the stable operation of the plant connected to the normal power supply. So in order to have a stable operation of any process or a plant, these loads are classified as essential category loads. These loads are subjective for automatic restart after momentary voltage dip and power failure to prevent shutdown, but not require a critical or emergency power supply. So there is a very fine line of difference between essential load and emergency load, which I will discuss in the next slide. But please understand, essential loads are those loads that we want to start immediately after the voltage has restored. But we do not give any backup like DG supply or UPS supply in this type of loads. Failure of power supply of this type of essential load at any duration has no safety impact on the plant safety. So if these loads also go out for some indefinite period, this will have no safety impact in the plant operation. When categorized as essential load, the feeder shall be equipped with reacceleration facility. So the motor has to reaccelerate immediately after the voltage has restored. So these are reacceleration facilities has to be provided in this type of load. Or third we call it critical load. So from the term you can understand critical means very very important. So these are the loads which can cause immediate shutdown if those gets failed or gets dropped, like instrument control. So these loads has to be kept in a position where plant has to be faster and more economically operated at this time. So you have to provide a 24/7 backup, continuous backup, and no cutoff of power supply is acceptable for critical use. So usually these critical loads are fed by a online UPS. Failure of power supply for these loads, like critical loads, at any duration has no safety impact in regard to plant safety, but there is typically high economic value to have not power outage or heat reduced source. These loads, as I said earlier, are fed from uninterrupted power system UPS or no brake flywheel generator without with or without diesel motor. Short brake diesel generator sets separate power sources. So we have to ensure that there is no cutoff in the power supply for these critical loads, because a millisecond drop of supply can disturb the online performance, instrument performance of the plant, which can eventually by its cascading effect lead to a shutdown or a safety impact on the plant. But on a direct level, these do not have a safety impact of the plant. Last but not the least are the emergency loads. So emergency, from its name you can understand. So for emergency or safe shutdown of the plant, these loads are classified as emergency load. So these loads require electric power for safe plant shutdown or to keep the plant in a safe status in case of power outage. The task is to maintain all emergency function for safety of staff and facility. For example, you can consider an egress lighting. Suddenly, if there is a power outage, the operator in the plant, right, if you do not provide an egress pathway light, then he will not be able to come out of the plant. So that is an example of emergency load. Similarly, there can be different types of process emergency loads also, right, which are identified that this would require an emergency power backup so that the safe shutdown of the plant can be ensured. The number of electrical emergency load should be reduced to a minimum by using fail-safe design. Very, very important. For equipment example, valves with spring energy store. So, these emergency loads are classified or identified by the process department. So ideally, process department tries to keep this emergency load minimum so that the backup of DG and other supply feeding the emergency load becomes less. They shall be normally supplied from a normal power supply source. In case of total normal power failure, they shall be supplied from an emergency backup power supply sources and restarted in sequence automatically after power supply is available. So once the power supply is restored, the main power is back. They are operated and restarted in sequence so that sudden load injection in the system should not cause a voltage dip in the power system.